We have two different combination of lamps that are wired in quite different ways, and they behave quite differently. This one on the right, which is called a series combination, we have wire coming in here. The current goes through this lamp, then it goes through this lamp, then it goes through this lamp, and then back to the power source. So in order for current to flow, it has to flow through each and every one of those. On the other hand, this is a parallel combination, and you see that I have the red wire attached to this point right here, this point right here, this point right here. Because these are wires and not lamps connecting the two of them, that means that there's no voltage drop. So this lamp sees the same voltage here as the original one did. It's the same voltage as coming out of the power supply. And the other ends of each of these are connected as well. So I'm going to take the systems here, and I'm going to turn on the juice, and I see that the parallel combination comes on first. And the reason for that is that each and every one of those is receiving, say, 120 volts, whereas over here the 120 volts is being split. This one sees 40, 40, 40. And so for that reason, oh, and let me just show you another thing. If I unscrew one of these bulbs, what happens to the others? They stay lit because they're still attached to the power supply. Now, I'm going to turn that off, and I'm going to disconnect that so I can focus on the series combination. So here we go. Starting to get them to glow. And you see I have them at about, what does that say? It says 130. I don't know if that's how many volts. I don't know if that's a well-calibrated scale. What happens if I unscrew one of these? Whoop, they all go out. Why is that? Because the current has to go through this one, then this one, then this one. And that means that if this one is not providing a path for the current to follow, then no current flows at all.